Hello everyone! This time we will review definite integrals and some techniques on integration. Please subscribe on my channel.
So we'll review first the types of integral. So first we have indefinite integral, what we had last time, and then the definite integral. So we are going to discuss a very simple definite integral example. So what is definite integral? If f of x is the integral of f of x with respect to x, that is the derivative of f of x with respect to dx, if a and b are constant. So we have here the definite integral is the integral of f of x with respect to x from a to b. A is the lower bound and b is the upper bound. Since definite integral, you are going to solve the region bounded, the area of the region bounded. So it's equal to f of x from a to b. So you can write like this. So the formula here, f of b minus f of a. So you will substitute the upper limit first minus the lower limit, where a and b are called the lower and upper limits of the integration respectively. So the definite integral link the concept of area to other important concepts such as length, volume, density, probability, and other work example. So we have here simple example. But before that, we will discuss the properties of definite integrals, very common. So if we have the theorem 4.7, if f and g are integrable on the closed interval a, b, and k is a constant, then the function k, f, and f plus minus g are integrable on a closed interval a, b. So we have the first formula, the integral of k times f of x with respect to x from a to b. So you transfer k outside the constant, then get the integral of f of x with respect to x from a to b. Second, the integral of f of x plus minus g of x with respect to x from a to b. You're going to distribute the integral. So the integral of f of x with respect to x from a to b plus minus the integral of g of x with respect to x from a to b. Note that property 2 of theorem 4.7 can be extended to cover any finite number of functions. So you can have f of x, g of x, and h of x, and so on. So you just again distribute the integral. So integral of f of x with respect to x from a to b plus the integral of g of x with respect to x from a to b plus the integral of h of x with respect to x from a to b. We have a very simple example. So we have here the integral of x cubed with respect to x from 1 to 2. So as we all know the formula, u to the n, the integral of u to the n is equal to u to the n plus 1 over n plus 1. So here 3 plus 1 is 4 over n plus 1. So 3 plus 1, 4 from 1 to 2. So we have here the solution since the formula is f of 2 minus f of 1. Upper limit first minus the lower limit. So substitute here 2 in x. So 2 to the power 4 is 16 over 4 minus 1 to the power 4 over 4. So 16 minus 1 rather over 4 is equal to 15 over 4. Another way of solving, we have the integral of x cubed with respect to x from 1 to 2. We have here, just substitute 2, the upper bound for x, so 2 to the power 4 over 4 minus 1 to the power 4 over 4. This is detailed compared to the previous example. So we have 16 over 4 minus 1, 4. So 16 minus 1 over 4, so it's still the same. The answer is 15 over 4. Number 2 example, the integral of 3x squared minus 4x plus 1 with respect to x from 0 to 3. So again, you are going to apply formula 2, distribute the integral for the subtraction and multiplication of integral. So we have here, if you have a constant property or formula 1, transfer the constant outside. So 3 times the integral of x squared with respect to x from 0 to 3 minus 4 times the integral of x dx from 0 to 3 plus the integral of x from 0 to the integral of 1 with respect to x from 0 to 3. After that, you apply the formula n plus 1, u to the n plus 1 over n plus 1. So here, 2 plus 1 is 3 over 3 from 0 to 3. If you have here, you apply the formula, no need to write the integral sign. So minus 4 times x squared over 2 from 0 to 3 plus the integral of 1 is x from 0 to 3. Substitute now the upper and the lower bound. So we have here, cancel 3 here. So 3 cubed minus 2. 4 divided by 2 is 2. Then you have substitute 3 squared plus 3. Since 0 raised to a number is 0. So minus f of 1, 0 cubed minus 2 times 0 squared plus 0. So final answer, 27 minus 18, this one, 9 times 2, 18, plus 3. The answer is 12. Example 3. Example 3, if you have here the integral of z over z squared, quantity z squared plus 1 to the power 3 with respect to z. So here, you consider the denominator as your u to the n. Apply getting the integral of u to the n. So we have here u to the integral of z over u to the n with respect to z. So you have here, your n is 3, your u is z squared plus 1. When you get the derivative of u with respect to z is equal to, we have here 2z. Derivative of u with respect to z is 2z. Then solve for du. You're looking for du. So here 2z dz. So du over 2. You are looking for z dz. So here you look for a function that will substitute z dz. So z dz is equal to du over 2. That's why here z dz is now du over 2. Copy u to the n. Simplify, it becomes 1/2 times the integral of du over u to the n. And then you get the integral of this one. 1/2 times the integral of u to the, transfer u to the n to the numerator. It becomes u to the power negative 2 or negative n with respect to u. Then apply here the integral formula. 1/2 times the integral of u to the negative 3 with respect to u. It becomes 1/2 times u to the negative 3 plus 1 over negative 3 plus 1. 1/2 times the quantity u to the negative 2. Negative 3 plus 1 is negative 2 over negative 2 is equal to 1/4 times, where did you get 1/4? This must be negative 4, sorry. 1 over negative 4, negative 1/4 times 1 over u squared. So you have here, that's a continuation here. Again, this is negative 4. 1 over negative 4, substitute u into z squared plus 1 squared. Then you will write here the upper and lower bound. So from 0 to 1. Then simplify, 1 over negative 4 times 1 squared plus 1 squared minus 1 over negative 4, substitute the lower bound, 0 squared plus 1 squared. Then you come up here, final answer, 1 over negative 16, this one, 1 over negative 4 times 4. This is 2 squared is 4. So negative 4 times 4. Minus, this is now 1. 1 squared is 1. So negative 4 times 1. 1 over negative 16 minus 1 over negative 4. Simplify, it becomes negative 1 over 16 minus 1 over negative 4. We have here, find LCD. LCD is 16. So copy negative 1 plus 16 divided by 4 is 4 times 1 is 4. So the answer, negative 1 plus 4 is 3 over 16.
Thank you for watching. Please don't forget to subscribe, like, and share. Please also watch my video about research, statistics, and calculus.